Hey scientists, welcome to our channel. We are the Snowball Geeks, and today we are going to explain the Snowball Earth hypothesis. Make sure to go check out our friend's website, which is also about Snowball Earth. Go to the link in the description box and it will take you straight there. Okay, so first let's start off with a general overview of what the Snowball hypothesis exactly is. So the concept of Snowball Earth was first proposed by Louis Agassiz when he claimed that the Earth was once frozen. Agassiz made geologists aware of past ice ages and extensive ice fields. But he turned out to be wrong about the fact that there were recent ice ages extending to the equator. His concept of the ice ages became the foundation for British geologist Brian Harland to support his own belief that there were glaciers in the tropical zone. Now this led to the formulation of the Snowball Earth hypothesis by Joseph Kirschvink. Kirschvink proposed that during the two cooling events, Earth became an ice surface, coated with frost and tiny crystals that settled in the cold and dry air. During the Proterozoic time period, there were two times when the Earth became an ice ball. Scientists suggest that the earliest phase took place about 2.2 to 2.4 billion years ago during the Paleoproterozoic period, and the second one took place around 750 to 680 million years ago during the Neoproterozoic period. Now, there are many causes that scientists hypothesize to have caused the Snowball Earth. I'm just going to list them out for you here, and then we're going to get into detail. So the first one is the rapid weathering of the continents. The second one is the increase in oxygen. The third one is the Earth's tilt. The fourth one is the high reflectivity, or the high albedo of the ice, or many believe a combination of multiple causes. Let's first start off with the first cause, which was the rapid weathering of the continents. Weathering involves the chemical reactions between compounds within the atmosphere and the compounds on the Earth's surface. So around the time when the Snowball Earth occurred, there was rapid weathering of the Earth's continents. Weathering of the rocks produced carbonate sediments that resulted in large amounts of atmospheric carbon dioxide being stored away for a long time. Now keep in mind, carbon dioxide is a warming greenhouse gas and is rapidly depleted from the atmosphere and causes temperatures to plummet, leading to the rapid cooling of Earth. So the next cause I'm going to talk about is an increase in oxygen levels. So this increase of oxygen levels was estimated by scientists to be about 2.4 billion years ago, which was about the same time as global glaciation. So a heads up, the information I'm about to present to you is very dense, and I'm going to try my best to break it down to you, or else it can be very confusing and baffling. Okay, so as the oxygen levels increased, the methane levels, which is a major greenhouse gas, decreased dramatically because the increased concentration of oxygen affected how much sunlight could actually reach the ground. And so when the oxygen concentrations are higher, the atmosphere disperses the sunlight, and the atmosphere itself becomes thicker. And this thick atmosphere decreases the amount of sunlight that is able to reach the Earth's surface, which means that less moisture is able to evaporate. So this causes the humidity and the water vapor to decrease. And when these two things decrease, there is less heat that is trapped in the Earth's atmosphere, and this causes the temperature to decrease drastically. This is basically just a chain of events, so hopefully the diagram will help more. The next possible cause of Snowball Earth is the Earth's tilt. During the two time periods when Snowball Earth occurred, the continents were in high latitudes. Now, when these places are in high latitudes, any decrease in temperature will result in the rocks being covered with snow and ice. This hinders the weathering process and slows the depletion of CO2. However, even when continents are in low latitudes, the accumulation of ice and snow in high latitudes does not decrease the depletion of carbon dioxide, and so the cooling continues until it reaches the equator. So basically it spreads from the poles down to the equator, or in the southern hemisphere's case, it starts at the poles and it moves up to the equator. So this process that I just spoke about leads into our next cause of the snowball Earth, which is the high reflectivity of solar radiation by the snow. Many scientists believe that these two causes are strongly correlated. When the cooling reaches the equator, the freezing process is aided by high level of reflectivity. Fun fact, scientists have found that ice reflects about 55 to 80% of incoming sunlight. And another fun fact for you, the sun was 6% fainter during the Proterozoic time period than it is now. This means that once the ice reached tropical latitudes, a positive feedback loop would take hold, where ice cover would lead to lower temperatures, adding more ice cover, which lowers the temperatures even more, and so this runaway effect would presumably continue until the entire planet froze. This coincided with the evolution of photosynthetic life, which would have drastically reduced greenhouse gases through the release of oxygen. Apart from these just being stated, they come with a substantial amount of evidence, and I'm going to present a little bit of it today. During the Proterozoic time period, scientists claim that the Earth's global mean temperature could have fallen around 12 degrees Celsius below freezing, because the days were shorter in that time period. They were only about 21.9 hours, which of course compares to today's 24-hour day, and this could have been a possibility for the Earth to be surrounded by snow. Additionally, supporting the positive feedback loop that I previously mentioned, the old rocks preserved signs of Earth's ancient magnetic fields from cooled small magnetite crystals that act as tiny compass needles when the lava solidifies. So these measurements of the rocks indicates that they were associated with the presence of ice that were formed in the equator. Now in the equator, there were small depressions in the land that were filled with water, and so that was probably where these rocks were found, and hence they were correlated to the presence of being near the equator. There is also evidence related to the glaciers and rocks that were formed from deposits of dirt and debris left behind when the ice melted. These rocks were dominated by calcium and magnesium carbonate, and these minerals lied just above the glacial debris, which provides chemical evidence that Earth had once been covered in snow. After hundreds of millions of years of burials, these now exposed rocks tell the story that scientists first began to piece together 35 years ago. Researchers Schrag and Hoffman bring their attention to a rock layer that represents the abrupt end of a 700-million-year-old snowball event. The light-colored boulder in the rock probably once traveled within an iceberg and fell to the muddy seafloor when the ice melted. Just to clarify, in the entire rock, there was this one section, this one piece of a white-colored layer, and this is called a quote-unquote cap carbonate, and these are the only types of rocks during the Neoproterozoic era that exhibited large crystal fans which accompanied rapid carbonate accumulation. Other researchers suggest that certain fossils that date around 700 million years ago, soon after the Earth became a snowball, did not exactly fit into any animal phyla, and therefore scientists believe that the fossils were sponge-like creatures that lived in low oxygen waters. So because the snowball Earth has not been proven yet, there are multiple hypotheses that people have come up with. For example, there are two hypotheses that can be considered if the magnetic evidence for the glaciation at the equator is correct. One of them states that the Earth's tilt, which is now at 23.5 degrees from vertical, was higher than about 54 degrees from vertical. This would have positioned the Earth so that the poles received the most solar energy and the equator would receive the least. This would have created a glacier around the middle, but still leaving the poles unfrozen. The other possibility is that the greenhouse gases in the atmosphere fell low enough so that over millions of years, glaciers gradually advanced from the poles to 30 degrees from the equator. Then in about 1,000 years, the remainder of the Earth rapidly froze due to the great reflectivity of the already ice-covered areas and their inability to capture heat from the sun. The entire Earth became a snowball with oceans frozen to more than half a mile deep. In addition to this, the scientists also wondered how on earth did living organisms at that time survive at such extremely low temperatures? After a long period of brainstorming, an American geologist, Richard Cohen, came up with a hypothesis that he named a slush ball Earth, which is a slushy, liquidy Earth. He claimed that the Earth was not completely frozen in the Precambrian times. Regions, especially oceans near the equator, could have been draped with a thin water layer of ice amid areas of open sea, because the ocean circulation would have prevented 100% freeze-over. If that was the case, photosynthetic organisms in low ice or ice-free regions could still capture sunlight efficiently enough to survive long periods of extreme cold. So, with all this being said, what other evidence are scientists still looking for that will change the hypothesis on Snowball Earth? Well, scientists are still looking for evidence on how living organisms throughout millions of frozen years, if existed, could have remained alive or appeared from who knows where. With the fact that oil contains molecular fossils or biomarkers, that shows what type of life the organism could have led. And astrobiologist Roger Buick of University of Washington and petroleum geochemist Adriana Dukiewicz of University of Sydney claim that eukaryotes and bacteria found in Ontario oil residues could have been alive throughout the Snowball Earth. But they refuted their own theory to be impossible when they realized that the long periods of thick ice coverage could have cut off photosynthesis for them to have survived. A geologist, Mark McMenamin of Mount Holyoke College, denied that even in the absolute darkness, there would still be survivors. Also, the current known existence of life forms within the areas with extreme temperatures, such as the hot springs and the deep sea vents, may also be another plausible reasoning. Although the Snowball Earth hypothesis explained how Earth froze into a snowball, it does not explain how the Earth thawed to be in its beautiful state of 2020. Alive, green, blue, brown, white, and colorful. The hypothesis on how the Earth warmed up again would be, drumroll please, the volcanoes adding CO2 to the atmosphere. As there was no weathering on ice and the frozen sea being unable to absorb carbon dioxide, the planet beautifully transitions from an ice house to a greenhouse. Without the depletion of CO2 from the weathering of the rocks, CO2 accumulates. In addition, it doesn't seem to have been used up, and thus the greenhouse effect, which primarily produces warmth, eventually melts the ice and snow covering the Earth. This process accelerates as the resurfaced soil absorbs a higher proportion of solar radiation. And sometime later on, the uncovered rocks begin depleting the CO2 and the process repeats. And at last, the cycle was broken by a tectonic movement that shifted continental mass away from the equator. So why is it important for people to know about the effects of snowball Earth to understand our current climate crisis? Well, climate change happens over the course of a pretty long period, and this is exactly what we've seen. Over the past millions of years, glaciers have shrunk considerably, ice sheets have been decreasing, the sea levels have been rising at a pretty fast pace, flowers are blooming faster because of the increase in temperature, and plant and animal ranges have actually shifted further up into higher latitudes. Because of the rise in temperature, they can survive up there. And this is all because the harsh cold weather does not really exist anymore. So as I explained earlier in the video regarding the gas increase, drastic escalation in the oxygen level was what filtered the sunlight, which caused the Earth to freeze. These greenhouse gases could not increase the temperature because of the thick atmosphere. William Menke from the Earth Institute at Columbia University explains that the temperature change correlates with the concentration of CO2 in the atmosphere. Data has shown the highest level being in the warm periods and the lowest levels in the cold periods. Since the carbon dioxide is not preserved, the geologists measure the concentration of CO2 trapped in the sediments deep in the ocean and other from fossil plant leaves. And so these results show a gradual decrease in carbon dioxide levels to be correlated with long-term cooling periods. But currently, it's quite the opposite. Human activities have largely contributed to a drastic rise in the greenhouse gas emission, especially the burning of fossil fuels such as coal, oil, and natural gas. This is known as anthropogenic climate change. Furthermore, it can also stem from deforestation. Therefore, the Earth is expected to have the complete opposite effect from that of snowball Earth. The IPCC, a team consisting of more than 1,300 scientists, predicted a temperature rise of 2.5 to 10 degrees Fahrenheit over the next century. According to their analysis, the effects would vary over time depending on the societal and environmental systems. Being able to predict the rise in carbon dioxide levels globally, scientists calculated considerable restrictions in human-related emissions to have a 70% reduction by 2050 and a net negative by 2100. News on global climate crisis impacting several regions support the seriousness scientists claim on taking drastic measures. Such evidence of droughts lead to famine. Earthquakes, floods, and hurricanes lead to homelessness. And a lot of people have begun to realize that this isn't only the scientists' problems, but everyone is a part of it. By applying the concept that led the Earth from the snowball Earth to what it is now, scientists are able to predict the temperature changes and how it'll further impact the world. It is important to take into account the causes and effects because by predicting the future of the Earth, we might be able to take measures against the similar negative consequences it might face. Thank you all for watching this video. We hope you enjoyed it and we hope you learned a little bit about snowball Earth. Make sure you like and subscribe, and don't forget to click the notification bell to get a notification every time we upload a video. And don't forget to click the link in our description box to go to our friend's website, which is also about snowball Earth, so you get double the knowledge. So make sure you go check that out. Thanks for watching.